Hi there! For this video, we'll be talking about the degree of a polynomial. But first, we'll define what degree of a term is. So let's write that one out. So when we say degree of a term, this is basically the sum of the exponents of a variable in one term. As present in our previous video, term simply refers to a quantity that is a product of variables, numbers, and constants. So for instance, if we have 3x, then we know that the variable out here is this x. So this is a variable. And by the I think the identity exponent property, this one is equal to x raised to 1. So we know that the sum of the exponents on variables in this term is equal to 1. And thus, the degree of this term is 1. So that is how we get the degree of a term. Let's try this second example. If we have 4x squared y squared, again, what we do is we add the exponents of the variables. In this case, we have two variables, and their exponents are 2 and 2. So adding that would give us 4. So the degree of this term is 4. Just like that. Now what if we have 3x y cubed z squared? So this one we have 3 variables. Again, the exponent of x is 1. It's not written there. And then we add these exponents. We have 1 plus 3 plus 2. That is equal to 6. And so, the degree of this term is 6. So that is how we get the degree of a term. We now dive into what a degree of a polynomial is. So when we say the degree of a polynomial, this is the highest degree among its terms. So again, to recall, polynomials are algebraic expressions or combination of algebraic terms with operations wherein the exponents of these terms are positive integers. So what we simply do is, given a polynomial, we check each of its terms and determine the highest among the degree of these terms. So let's have an example. If we have x cubed plus 2x squared plus 3x plus 1. So for this one, what we do is we check each of their individual degrees. So for the first term, its degree is simply 3, since the variable is x and its exponent is 3. For the next one, its degree is 2, since the variable is x and its exponent is 2. For this one, 3x, its degree is 1, since its variable is x and that exponent we know is 1. How about for the last one? For the last one, its degree is 0, since it does not have a variable. And if it does, its exponent is simply 0, since x raised to 0 is 1. So among these degrees, we know that the highest one is this one. So the degree of this whole polynomial is 3. So that is how we get the degree of a polynomial. Let's try this next example. If we have 3a plus 4b squared c squared plus 3d3f squared. So now this one is more complicated than the first one, but we simply check the degrees of each term. So for the first one, our variable is only a, which we know to have an exponent of 1 since it's not written there. So the degree of this one is 1. For the next one, for the next one, what is its degree? Well, we have two variables, b and c. So their exponents are 2 and 2. And so we add these exponents, since these are the exponents of the variables. So 2 plus 2 would give us with 4. And for the last one, we have 3de raised to 3 and f squared. So what is the degree of this one? Again, we have three variables here. We have d, e, and f. For d, since it's not written, we know that it has an exponent of 1. Then so we add the exponents of the variable. So we have 1 plus 3 plus 2. So the outcome of that one will be 6. So comparing again its terms, we know that its degree is 6, since it's the highest among these three terms. And so the degree of this polynomial is 6. Let's have one last example. If we have 3x y squared z raised to 4 plus 4a raised to 4 bc raised to 5 minus 5r cubed s raised to 4 t raised to 4. So again, more complex one since there are more variables and exponents, but we do the same process. For the first one, we add the degrees of these exponents. So x has, we know, a degree of 1. Then we add 2 and 4. So 1 plus 2 plus 4 would give us a degree of 7. For the next one, we have the exponents of the variables a, b, c. So 4 plus, since b doesn't have an exponent out here, we know that it is 1 by the identity exponent property. Then we add 5. So 4 plus 1 plus 5, that would give us 10. Yep, 10. And then for the last one, we add the exponents of the variables r, s, and t. So we have 3 plus 4 plus 4. So 3 plus 4 plus 4 would give us 11. And so we know that the degree of this polynomial is actually 11, since that is the highest degree among its terms. So that is how we get the degree of a polynomial. Simply recall our knowledge on terms and variables, so we know which among these exponents we choose from. Since we can have, say if we have 3 cubed out here, we won't need to include the 3 in the adding of the exponents in here, since 3 is a numerical value, or it's a constant, so we don't treat it as a variable. So recall that idea on variables, and then terms, which is simply just this one, because when there's an operation, that becomes an algebraic expression, and further to be a polynomial. So take note of these, and that is basically it. This is how we get the degree of a polynomial. And so that is all for this video.